Okay, physical or non-organic acids. Those that, organic means you have carbons that are bonded together in a structure. We went over that just a little bit yesterday. So what we're going to do is acids that, generally speaking, don't have carbons bonded together. Now, in this category, there are two broad categories for naming. We have the binary acids. We have the binary acids. And we have the oxy acids. Now, binary means you have two elements, not necessarily just two atoms. Okay, that's the definition I gave you earlier. Excuse me. If I'm not mistaken, it's also on this sheet. Binary. Okay? But binary means two elements, not necessarily just two atoms. Now, there are some, I guess, rare in a sense, but they're not rare in the sense they're out there. They're common in the sense there's a lot of it, but we don't face it very often. In binary, we also include the polyatomic ions with no oxygen. Okay, so this naming system applies to those polyatomic ions that have no oxygen. Oxy acids, all of these acids are going to contain polyatomic ions that have oxygen in them. Okay, so all of these will contain polyatomic ions. With oxygen. And the formula. Okay? So most of the binary acids will have monoatomic anions. Most of the binary acids will have monoatomic anions. All right, a little bit of background now. Acids only work like acids when you put them in some kind of solution. When you put them in a solvent. All right. If I have an acid that's a pure, it's not mixed with anything. Okay. It can be either a crystal or it can be a molecule. All right. So acids don't really fit cleanly into either covalent or ionic categories. Okay, sometimes they're one and sometimes they're the other. What makes an acid an acid? What makes an acid an acid? And there are several different definitions for acids and several different ways of thinking about it. The simplest of the ways of thinking about it is this. What makes an acid is it's any substance that will put hydrogen ions in solution. Any substance that will put hydrogen ions in solution. An acid is any substance that will put hydrogen ions in solution. So when you dissolve it, it'll put hydrogen ions in that solution. It will put hydrogen ions in solution. Okay? So, all of our acid formulas in this class will have hydrogen on the front of the formula. Okay? All of our acids in this class will have hydrogen on the front of the formula. So we can pick almost any nonmetal we want out of our periodic table and put hydrogens on the front of that nonmetal, and we got an acid formula. Okay? With the possible exception of water. H2O. It actually can be an acid, but we don't often think about it that way. All right? So let's put hydrogen in front of F. Okay? So here's the hydrogen, and here's the fluorine. So let's find your periodic table with oxidation numbers and tell me what charges to put on those. One plus and one negative. Okay. Now the hydrogen ions that we're going to put on all our acids are always the positive ions. The hydrogen ions we're going to put on our acids are always the positive ions. Okay? And then we put them together, we get HF. Okay? So when we're naming acids, we're going to start by treating our acids like ionic compounds. Okay? Sometimes they're covalent, sometimes they're ionic. In its pure form, this is actually covalent, but we're going to treat all our acids like ionic because we're going to first name them like they're ionic compounds and then change the name to the acid name. Okay? So we just practiced naming binary ionic compounds. Name this like a binary ionic compound. On your paper right now, in your notes, name this like a binary ionic compound. We just did it a few minutes ago, do it now. Name it like a binary ionic compound. Did you get hydrogen fluoride? Very good. Hydrogen fluoride. Okay, so that's where we start. But since it's an acid, and you can tell it's an acid because it's got the hydrogen on the front, okay? Everything except water, if it has hydrogen on the front, you can reasonably assume it to be an acid in this class. Got that? All right, that's not hard, is it? Hydrogen on the front, what is it? Except for? There you go, except for water. There you go. All right, so here's what we're going to do. We're going to change the name now. I don't know why I put an R right there. It should be hydrogen. Hydrogen. All right. Now, when we have a binary acid, these rules apply to binary acids only. Okay, we got a different set of rules for oxy acids. We're going to get rid of the gin. Okay, we're going to get rid of the gin. All right? People should stay away from gin anyway, shouldn't they? I'm going to tell you in a second. So get rid of the gin. That's my joke. It's against the law for high school students to be messing around with gin anyway, isn't it? Oh, man. Y'all are slow today. Okay. All right. What? Okay. All right. Now, IDE. The IDE ending, we're going to get rid of it too. We're going to replace it. We're going to replace it with IC. Okay? And then we're going to plug the word acid on the end of it. Okay? So let's rewrite the whole thing now. Now that we've done all this marking out and stuff, let's put it together. The hydro actually becomes a prefix on the fluoric. So it's one word, hydrofluoric. And then the word acid. Okay? Hydrofluoric. Got that? All right, does that seem particularly hard? Not if you got the ionic naming stuff down first. If you do the ionic naming stuff down first, then this becomes a little bit easier. All right, but you got to get the ionic stuff down pretty solid first, which is one of the reasons why you had a worksheet you're supposed to do last night. You got two more worksheets to do today on ionic compounds because you can't name acids without that first. Okay, and it's the hardest system to get a handle on. All right, at least so far. Okay, all right, let's try another one. Why don't we put together hydrogen and sulfur? Hydrogen and sulfur. We're about to run out of time. And I need to get to, I won't help you through this because we're running out of time. Okay, sulfur's 2 negative. And we put it together, we get H2S. Okay? What are we going to name this one? What are we going to name this? Ionic first. How are we going to name it? Hydrogen sulfide. Right? Got to have the ID ending. Okay, hydrogen sulfide.
What's the anion in that one? Would that be a
Sulfur. There, it's negative. That's the negative part. Hydrogen sulfide. Okay. So what are we going to drop off of this? Gen goes away. We're going to plug that hydro as a prefix on that sulfur over here. Okay. And we're going to change the ending to IC. So that's hydro. Okay, but with sulfur we put the UR back on there because it sounds better. Hydrosulfuric acid. Okay? Hydrosulfuric acid. Doesn't that sound better? Okay? We put the UR back on the sulfur, we put the OR back on phosphorus when that happens. But if you don't get that just yet, we'll practice some more. Okay. Let's look at oxy acids real quick. The instructions are on the sheet here. Okay? The instructions tell you what to do. They're right here. Oxy acids have polyatomic ions on them. So if I have SO3 and H2 on the front, okay, this ion, SO3, is a sulfite ion. Okay? So we name it like an ionic compound. It's hydrogen sulfite. When we name acids with oxyanions, Rachel, pay attention. When we name acids with anions that have oxygen in them, we drop hydrogen off the front entirely. Okay? 8 endings get changed to ic as well, but ite endings get changed to OUS. Okay? And again, with sulfur, we put that UR back on there, we get sulfurous acid. Okay?
So when you drop hydrogen, whenever it's in
We drop hydrogen off any acids that have polyatomic oxyanions. Now, the 8 and ic stuff is all up here in the definitions. Make sure you read the definitions and get this worksheet done tonight, okay?